Hello and welcome to the channel Let's Learn Electronics. In our last two videos, we solved two numerical problems on the topic of zener diode. This video is also in continuation to the past two videos. We are going to solve the third and the last numerical on this topic. The question says, for a Zener diode network of figure below, determine the range of Vi supply voltage. This Vi that will maintain the voltage drop across load at 8 volts, 8 volts throughout without exceeding the maximum power rating of the Zener diode. So we have some information given in the circuit diagram. The limiting resistor is fixed at 82 ohm. The breakdown voltage of the Zener diode is 8 volts. The maximum power dissipation is 400 milliwatt. The load resistor is fixed at 0.22 kilo ohm. The VL, the voltage drop across this resistor, is maintained at 8 volt throughout the operation, and we need to calculate the range of Vi, the minimum and the maximum supply voltage which is required for the circuit to successfully perform its operation. In the last videos in which I discussed the theory part of this topic, I explained these formulas. If you have not watched the previous videos, please go back to the channel, watch the theory part on this topic. It will help you in understand the question in a better way. Anyways, let's proceed ahead. We have this formula Vi minimum is equal to Rs plus RL into Vz upon RL. This equation will help us in calculating the value of Vi minimum directly. We have all these parameters given in the circuit in the question. So we need to directly put the values in this equation and we can calculate Vi minimum. Let's enable the pen and start writing. In order to calculate Vi minimum, we have these values. I have directly written it here. Start solving it side by side, scribble on a paper and try to calculate these values. 82 plus 302 gives us, adding 82 plus 220, it's 302. We have converted the kilo ohm value into simply ohm. So 220 plus 82 is 302 into 8 volts upon 220. I have simply put the values in the equation. This is what we get. 2416 upon 220. Use a calculator. I am using a calculator over here. And if you calculate it, it should come out as 10.9 volts. Forgive my poor writing. It's the Vi minimum is 10.9 volts. Now let's calculate the maximum value of power supply. In order to calculate the Vi maximum value, let's look at these equations once again. When the branch of Zener diode will be having maximum current flowing through it, when it will have Iz maximum, then the limiting resistor will have its maximum, it will reach to its maximum value Is max. Let me show you the circuit. This is the circuit when this branch Iz will be having a maximum value of current flowing through it. IL is fixed. This is maximum. Then in those circumstances, in that situation, this resistor IR will be having the maximum current flowing through it. So if we sum up if we calculate the value of this Is maximum, using that value we can calculate the maximum possible voltage drop across the limiting resistor, this Vs max. We can calculate this value, and summing up the Vz plus Vs max, we can calculate a Vi maximum. I have explained this formula in my last video. Please watch that theory part first. Now let's directly put all those values in the given equation. We have, in order to calculate Vi max, we have Pz maximum given in the question. So using Pz maximum and Vz, we can calculate the value of Iz maximum. we need to, for this, we need to calculate IZ maximum first. When Zener diode would be having the maximum current flowing through it, we can calculate the highest possible value of the current flowing in the limiting resistor. So we have 8 volts. We have these values 400 milliwatt. 4, let's write 400. This is what we get. 50 milliampere is the value of IZ maximum. Now once we have calculated IZ maximum, let's calculate the value of IL, the current flowing through the load resistor, and all the parameters are fixed in this case. The VL is maintained at 8 volts. The IL, using Ohm's law, we can simply calculate IL. We have EVL fixed at 8 volts. RL is given as 0.22 kilo ohm. Converting it into ohm, we get this value. And if we calculate it, you should be getting 0.3 0.036036, something like this, ampere. Let's convert it into milliampere. This is what we get, 36.3 milliamperes. We have got the value of IL now, 36.3 milliampere. We have got the value of IZ maximum, which is 50 milliampere. Let's add them and calculate the value of IR or IS maximum, the current flowing through the limiting resistor. So 50 plus 36.3 is 86.3 milliampere. IS maximum is 50 plus 36.3. This is what we get, 86.3 milliampere. We can orally calculate it. It's so simple. And now we need to put the values in the equation of VI maximum. VS maximum should come IS max 86.3 amperes. I have converted it into ampere from milliampere value. IS into RS, the limiting resistor, 82. So we should get 7.07 volts. This is the value of VS maximum. So for VI max, we need to add VS max plus VZ. 7.07 plus 8 volts, it should come 15.07. I can orally calculate that. Let's just write it quickly. This is the value of VI maximum, 15.07. So we have successfully calculated the range of power supply which is required. It's 10.9 volts to 15.07 millivolt. Let me summarize these values like this. This way we have calculated VI 10.9 volt minimum to 15.07 volt maximum. If you have not watched the previous videos, please go back to this channel, and we'll be coming up with more uh, topics related to our theory part from the syllabus via basic electronics, and we'll also cover more numerical problems. So stay connected, press the bell icon to get the regular updates, like the videos, subscribe to the channel, and keep watching and learning with Let's Learn Electronics.